Okay, now I will give you an overview of the options of disposal of radioactive waste. Before we go into detail, let's talk a little bit about the disposal terminology. Disposal means this is the emplacement of waste in an appropriate facility without the intention of retrieval. This means the waste should stay at the disposal site forever. And a disposal facility, this is an engineered facility where waste is emplaced for disposal, of course. There are near-surface disposal facilities which are located on the Earth's surface or within a few tens of meters below the ground level. So everything is very shallow. And in contrast to that, there are geological disposal facilities. These are facilities for radioactive waste disposal located underground and usually several hundred meters or more below the surface. And a stable geological formation is needed to provide this potential for long-term isolation of radionuclides from the biosphere. So, the aims of disposal of radioactive waste is quite simple. It's to contain the waste, to isolate the waste from the accessible biosphere, and also to reduce the likelihood of inadvertent human intrusion into the waste. I mean, the knowledge about this disposal might get lost, and future generation might look for some, due to mining activities, might look for some commodities and may unintentionally intrude the disposal, and this should also be avoided due to design features. So, if we look at the current status of disposal of waste, I mean, several designs have already been developed for disposal facilities, and these designs have a different degree of containment and isolation capacity, and this depends on the type of waste and the activity which should be disposed of. I mean, in some countries, various types of disposal facilities have been constructed and are already in operation. So let's have a look at the waste classification scheme. There are a number of classes dependent on the half-life and also on the activity in the waste. First of all, this is high-level waste, and high-level waste is mainly spent fuel or waste from reprocessing. And we have intermediate level waste and low level waste and very low level waste and very short-lived level waste. These are all, this is so to say, the categorization depends on the activities which are present in the waste or on the half-life. And something is also about exempted waste. This is waste which is radioactive but which cannot be managed. For example, this could be waste containing potassium-40 from fertilizer, something like that. And here we have again this very short-lived waste, very low-level waste, intermediate level waste, high-level waste. And depending on the activity and half-life, I mean, the lower the activity or the higher the activity, the greater should be the depth at which the waste is disposed of. So high-level waste goes to the deep underground, to geological disposal, whereas very low-level waste and low-level waste can stay on the surface, of course, with some technical barriers. So this is an example of a near-surface disposal. This is for short-lived radioactive waste or for lower activity sources, and this can be found in some countries. Geological disposal is not available yet, and then we have, but geological disposal is going to be, or licensing procedures are going on in Finland and Sweden to construct and operate such a geological disposal facility for high-level waste. An idea which came up during the last years, or at least 1 or 2 decades, is a borehole disposal. This is could be appropriate in particular for countries which don't have big nuclear programs, but which have only some sources for medicine or for research, because this borehole disposal, this is suitable for all types of disused radioactive sources, and it provides a safe and secure solution, and one has not to wait for until a geological disposal is finished or is in operation. However, borehole disposal is also not available yet. It's still an idea. So all of this, we have this disposal system consisting of the confinement where the waste is disposed of, the geosphere with the overlying rock, and the biosphere. So, and if you go again for the terminology, when we look at the containment, these are methods or physical structures to prevent or control the releases and the dispersion of radioactive substances. And the confinement is a prevention or control of releases of radioactive material to the environment in operation or in accidents. And the most important point for disposal is the isolation and the isolation capability. And isolation means this is a physical separation and retention of radioactive waste from people, away from people and the environment. And this may need to look at time frames of several hundred years for short-lived waste. I mean, short-lived is, for example, also in this context, is also cesium-137 with a half-life of 30 years. So several hundred years would be 10 or more than 10 half-lives of cesium-137. However, intermediate level waste and high level waste has to be looked at more carefully, and the period is at least for several thousand years. And this isolation, of course, this is an inherent feature of geological disposal. So the disposal system, where we have the near field with the types of waste, the origin, the nature, the quantities, and the properties of the waste. And finally, the radionuclide inventory. Then we have some system engineering for waste conditioning and packaging and disposal units, and engineered barriers that cover the disposal facility and drainage features. And we have also to know about the extent and property of the zone disturbed by any excavation or construction of the work. And all these features have to be taken into account then in the safety assessment. And we have also the far field. And the far field is a way from the facility to the biosphere, and it includes geology, hydrology, hydrogeology, geochemistry, and finally the biosphere with the location of the disposal facility, climate and atmosphere, water bodies, the biota, the salts present, the topography and the area of this the site, and of course the local population and human activities. So let's talk about some examples for planned or existing disposal facilities. Let's start with the near-surface facility, which is a landfill for very low-level waste in Lithuania. And this is just a buffer storage facility. And it is located close to the Ignalina nuclear power plant in an industrial site. It's in operation. It's low-level, very low-level waste. It contains relatively low activities. And the waste is stored, is disposed in such disposal modules. We have the waste in the inner side, and here we have some barriers to prevent that the waste enters, can enter to the biosphere. And this is also in Ignalina, in the zone of the nuclear power plant. This is the same again, Ignalina. Here you see the waste packages. Waste is compacted, or it's packed in such flexible intermediate bulk containers. Again, here's the waste, and this is surrounded by barriers to prevent leakage. This is a near-surface disposal facility in France, and it is for very low-level waste. You see here some pictures. This is a facility, and all works disposal in this facility is done under this mobile shelter. And there are a number of mobile shelters. This facility went into operation in 2003, and it is dedicated for very low-level waste, and it was the first of its kind in the world. In this facility, about 30,000 cubic meters are disposed per year. There are trenches nearly 180 meters long and 25 meters wide, and they are dug several meters deep in a clay layer. And after filling, the trenches are covered by a capping system composed of natural materials and a geomembrane, ensuring water tightness. As I said, all operations are conducted under the mobile shelter. The mobile shelter can be moved from one trench to another on a rail sliding system. And the interesting thing is that disposal cells are excavated directly in a clay layer down to a depth of 8 meters. And these cells or the trenches are operated one by one. If one is full, it is closed, and then disposal and the next one starts. So in this case, only one of these trenches is open, all others are covered. And when people work on it, then it is covered by a shelter to prevent intrusion of rain and water. And here you see the profile. The disposal trenches are between 0 and 30 meters underground above the water table. And this trench is dug into the clay. And in the post-closure phase, everything is filled with material which prevents the intrusion of water. This is another example of a near-surface disposal. I mean, these yellow barrels are very famous. They are disposed here in these layers and then covered by material. But this is not in France, this is somewhere else. Here we have the example of a near-surface disposal facility in El Tabril, Spain. It is also for very low-level waste, for low-level waste and for intermediate-level waste. Everything is above ground, and these are, so to say, the technical barriers for this disposal. And here you see a scheme of this disposal facility. I mean, this is very simple. This is just a big concrete structure which is protected against wind and weather. This is a planned near-surface disposal facility in Belgium. This is for category A waste. Category A waste is short-lived waste with low and intermediate level specific activity. I mean, it's mainly short-lived, but may contain also some other stuff. This is done about for 50,000 cubic meter, and this is about 0.5% of the total activity of all waste. And this looks like that in the operational phase and in the post-closure phase. Then it will be covered by some material. This is again in this Belgium example. So there are three types of monolith which are used for the disposal of waste in this structure. And this disposal facility has a fixed steel roof attached to modules, an inspection room, and an inspection gallery to allow inspection. Let's come back to the borehole disposal activity for radioactive sources. Here a bit more detail. So a hole is drilled to the underground with a depth of 100 meters or more. Then the waste packages are filled into this hole, and then everything is backfilled with some material, often bentonite, which has some sorption effects. And we have a repository seal, and yeah, and then that's it. It's quite a simple concept, but it's only applicable for sources with a very small volume. It's nothing for large volumes. Yeah, you can see again. Also, this canister has also some barriers. This is a container of the source. This is a capsule. Then we have some backfilling and another barrier. So there's a number of barriers. There's a multi-barrier system to prevent that this material can leak. This is in Sweden. This facility was designed for disposal of short-lived radioactive waste with low and intermediate level specific activity from nuclear power plants, hospital, industrial users, and facilities. It is underground. This is a Baltic Sea. This is a shoreline. And it was built between 1982 and 88 at a depth of 5 to 100 meters in a structure under the Baltic Sea floor, about 1 kilometer away from the Forsmark nuclear power plant. And the waste here is deposited in cavities which were excavated into the rock, and to be flexible in configurations that the waste fits well. This facility is in operation since 20 years. Close to this area also the Swedish disposal facility for high-level waste is planned to be constructed. And as you see, this is on the shoreline. It's under the seabed, and this landscape will change in the next thousands or 10,000 years. And all this water, what you see here, due to the lift of the landscape, this water will disappear and the sea will fall shallow. This is a new disposal facility also in Sweden in the same area, and this is for intermediate level waste. This is a similar design. It is underground in very old granite, and the waste is then stored in such structures. The structures are sealed, and at one point in time everything will be closed. Let's go to the geological disposal for high-level waste. Again, the high-level waste is also in Sweden. The host rock is granite. This granite is very old, I think billions of years, pretty old. And in this granite, caverns are excavated, and the waste is put into such holes. And these are these copper canisters with a height of 5 meters. The copper canisters have a diameter of 1 meter, and the mass is about 25 tons. So it needs huge machinery to handle this stuff. Then they are put in this hole and then sealed. This is copper. Copper is used because this is granite. In granite there's always some, it's not a dry, it's not a dry host rock, because there's always some pores or some cavities, some passes where water might infiltrate. And that's why this copper has been selected, and this should seal the waste for a very long time. And in total, a huge amount of copper will be disposed of also in this disposal facility. Here you see such a copper canister, and this will be fixed. This is the upper part, and this will be fixed to that. So, and this copper goes into this gas goes in. No, let's start with the spent fuel. There's a containment for spent fuel, and this spent fuel containment goes into the copper canister. The copper canister is sealed, and this is then put into the caverns in the crystalline bedrock. And here is the depth of 500 meters. And the canisters are surrounded by bentonite clay in individual deposit holes. I think the total cost of this, at least the estimation, which was communicated to me 2 years ago or 3 years ago, was about 10 to 12 billion euro. This is about 10 to 12 billion dollars, something in this order of magnitude. And this is some geological disposal for high-level waste in Finland. It's in principle similar. The host rock is the same. It's also granite. And again, there's the fuel. The fuel goes in the assembly, in the canister in the rock, in the copper, in the bedrock, and then fulfilled with bentonite for sealing at a depth of 400 to 500 meters. And this is disposal for high-level waste in Finland. It's also close to the sea. And Finland, very likely, it will be the first ever facility for the safe disposal of spent fuel. This is in Finland. You see a cavern in the bedrock, in the granite. So granite is a very hard rock. So you can imagine the efforts to construct such caverns. This requires really special equipment. I mean, this disposal is called Onkalo in Finland, and it consists of a system of such tunnels. And also this system, or these tunnels, are also used to characterize the host rock, which is also then important, provides important input for the development of the safety case and the safety assessment. So, this is an example from the United States. And this is a so-called WIP. It is a waste isolation pilot plant, and it is authorized to store transuranic radioactive waste for 10,000 years. And the waste is from research and production of United States nuclear weapons. Yeah, it's quite similar. They are underground caverns, and they are stored or disposed of in special containers which prevent which gives an additional potential for isolation. There's also in Germany one example. It's a geological disposal of low and intermediate level waste. The planning started, I think, in 1982. There was a first safety report on this. This is a disposal site in a former iron ore mine near Braunschweig in Germany. This is more in the north. So I said the first plans were in 1982, something like that. Now the schedule is to start in 2022. Could also be a few years later, I don't know. and the maximum capacity is about 300,000 cubic meter of waste. It is an old iron mine. This mine is very dry because over the iron mine there is a very thick clay layer which prevents rainwater and groundwater to go into this disposal facility. Okay, let's come to the summary. I mean, we have seen some examples of waste disposal facilities, both for low-level waste, but also for medium and for high-level waste, and these concepts and which are in construction. So I think it's important that to know that we can learn from other member states' experience and design solutions, and to know what works well and what works not so well, to have a continuous improvement of such disposal systems. We have also seen that there are maybe many ways of providing long-term safety and many concepts. And obviously there's no single best disposal solution for near-surface or geological waste. Everything depends also on the geological circumstances in a country. I mean, the Swedish disposal facility is in granite because they have only granite as an appropriate host rock. In other countries, there might be also salt formation which are suitable for waste, or clay formations which are suitable for waste. So this depends on country by country. And I mean, we have different kinds of waste, so we need also different types of facilities. And they have to be designed in an optimal way to address the disposal inventory, and also to take into account the characteristics of the sites and the available resources. Technical and natural barriers need to be explored and evaluated to assess the long-term safety. And this is a key element for the development of the safety assessment and the safety case. And as this is quite a long-term process to come up to the construction and the design and construction of disposal facilities, it is also kind of a continuous iterative process between design and safety assessment facilities, and looking at it in a holistic view, considering the whole system. Thank you very much.